Gondwana and Pangaea. We all heard about ancient supercontinents, Gondwana, Pangea, Laurasia. But what does it mean for our Earth? Did they existed? How we know about this? What effect they had on our life, climate, and geology of our planet? Let's in this video talk about Gondwana, Pangea, and the supercontinent evolution on our planet Earth. If you're a geologist, probably you know these names, but you're not very sure what does it mean. What is a Gondwana? Gondwana, it was a long-lived southern hemisphere supercontinent that united with other continents to form Pangea. And it all happened in the late Paleozoic times. The existence of Gondwana was hypothesized firstly by Edward Seuss in 1861. However, it was very speculative and no evidence that time existed. In 20th century, Wagner's theory of continental drift claimed that continents has been displaced over time. And only later, in the mid-20th century, people could prove it directly with the intensive studies of the bottom of the ocean. In my previous videos about plate tectonics and conversations about plate tectonics, I talked about this in a great detail. So watch those videos to learn more. About half of a billion years ago, 550 million specifically, the slow drift of the Earth's tectonic plates produced a supercontinent named Gondwana. Gondwana dominated the southern hemisphere at that time. This huge landmass survived for more than 400 million years, and it had a profound effect on the evolution and distribution of life on our planet. But let's find out if it was the only continent of such a sort on our planet, and how people know about this. In the Earth's history, there's a constant rearrangements of large-scale continental mass masses since the oceans have formed, grown, and ultimately been destroyed. And occasionally, these processes bring the continents together, forming massive supercontinents, such as Pangea or Rodinia, if you heard about that one. But we talk about Gondwana because it was the first one that had been identified by Austrian geologist Edward Seuss in 1861. At the times, though, this theory of the formation was a little bit different. Seuss explained the presence of similar plants on widely separated continents through a change in the sea level, rather than what we know now, rearrangements of the continents due to the continental drift. Many scientists at that time, or even in the 20th century, still believed in trying to prove that the Earth's plates doesn't move horizontally, but rather vertically. The sea level changes and there being land masses exposed, creating large continents and helping animals and plants to move in between land masses, like for example between South America and Africa. And then this land masses separated by the oceans again. I talked about this in a Plate Tectonic Conversations video about some theories about shrinking Earth's crust and as a result collapsing some places, creating the oceans. However, 50 years since the Seuss, Alfred Wegener explained Gondwana using the continental drift theory and called it as part of even larger landmass, Pangea, which we know dominated the late Paleozoic and Mesozoic world. You can think about this if all the continents constantly moving in different directions on the surface of the globe Earth will be the point when we'll collide. We see the large example of collision of Indostan plate with Eurasia, creating the biggest mountains, Himalayan, on our Earth today. However, in the past, it might happen more often. European Alps creating right now by moving Africa towards Europe, and eventually they will form one big landmass closing the Mediterranean Sea. Similar, the landmass of the England was brought together by different pieces, or New Zealand land. With the Alpine Fault, it's the place where the Australian plate meets the Pacific plate. Therefore, these things happen all the time, and geologists, as a detective of the Earth, trying to figure out which landmass moved where, what it was in the past, and what's going to happen in the future. Right now, we have separate continents all over our globe, and it's quite dispersed, with open cracks of the ocean in the mid-oceanic ridges, creating the oceans in between the continents. At some point, the continents will move back together again. You would think that Pangea was the only one, the supercontinent in the past. However, it's not as true. There was many more before. However, Pangea is quite significant because how it's affected the development of our life. One of the biggest in the past before, it was Rodinia as well, the continent. And the breakup of Rodinia coincided with major development in the history of life. That's when the primitive life started developing into a more complex one. Rodinia, named after the Russian word Rodina, meaning the motherland or the homeland in English equivalent, is the supercontinent that saw most of the world's continents united in a single landmass. However, it happened so long time ago, not like Pangea or Gondwana, and it's very hard to reconstruct it. The more into the past geologists move, the less evidence we have survived, and the harder to reconstruct what happened back in the day. So how do we know about what's happened in the past? Well, discovery that the Earth's magnetic field can be fossilized in certain ancient rocks has revolutionized our reconstruction of Earth's geological history. Iron-rich mineral grains align to the prevailing magnetic field before solidifying into rock, and therefore preserve their original orientation relative to magnetic north, and even their latitude, thanks to the angle of a magnetic tip that varies with distance from the poles. What is more, the remnant magnetism of seafloor rocks retains detailed evidence for the way in which the ocean crust has developed and moved over the last 180 million years or so. Alongside plate tectonic theory, this has allowed geologists to model the past movement of the many jostling crustal plates with great precision. However, there's everywhere its own disadvantages. The slight drawback of this paleomagnetic technique is that ancient continental rocks alone can only provide magnetic data about the latitude. Establishing the longitude, especially before 180 million years ago, so when we don't have any more ocean sediment preserved, when the help provided by the ocean crust begins to be diminishing, we require other data. People study geological history and paleontology of the continental landmasses and surrounding shelves, and it helps to fill these gaps. However, it's allows fairly accurate plate reconstruction back to the beginning of Cambrian times, more than 440 million years ago. However, the further in time we go, the more problematic and debatable these reconstructions began. That's when we study the Cratons, the remnants of older land masses. We talked about this in my previous video about the oldest rocks and plate tectonic. Gondwana, associated with South America, Africa, and other Cratons such as Arabia, India, Antarctica, and Australia to the east, and there was a great southern landmass, Gondwana we know today. However, it wasn't specifically a similar landmass which we observe right now. They were modified and changed since, but the main base of the rock preserved. Within Gondwana, magnetic arcs, where subduction and disappearance of the ocean floor triggered volcanic activity in the overlying Craton, marked the junctions of the Trans-Sahara and Congo Cratons with Arabia and Eastern Africa, while other collision zones mark the attachment of Southern Africa, Eastern India, Antarctica, and Western Australia. Gondwana began to come together in late Precambrian times through the amalgamation of two previously assembled clusters of ancient Cratons. And as we say, Eastern Gondwana was formed from the African, Indian, Antarctic, and Australian Craton, while Western Gondwana consisted of the South America Cratons. It was a long business, the process of formation. And its story is told in the ancient mountain belts formed as the Cratons converge. Similar like we talked, modern Himalayas are forming. And the final phase of formation was about 550 million years ago, when India and Australia converged in Eastern Africa, while the North America Craton, Laurentia, began to drift away from Gondwana as the southern polar sea, called the Iapetus Sea, opened between them. It's probably no coincidence that the later stages of Gondwana formation saw the appearance of the Ediacaran biota, first large organisms, and its final assembly coincided almost exactly with the Cambrian explosion in diverse marine life. We talked about this in the mass extinction video if you want to learn more. What was the main effect of this supercontinent? Climate effect. We can observe the climate effect. 15 million years after Gondwana formation, the process that had opened the Iapetus Ocean were driven into reverse. Laurentia began to drift back towards the supercontinent alongside other major cratons such as Baltica, Northern Europe, and Siberia. Throughout this period, significant global climate change saw the development of existence equatorial swamps and rainforests across modern North America, Western Europe, and Russia. And the vegetation in these ancient biodiversity hotspots decayed and transformed into sedimentary coal-bearing rocks we know now. By late Carboniferous times, around 290 million years ago, the global climate cooled. The extensive vegetation had removed huge amount of carbon dioxide from the atmosphere and now locked away in buried plant debris. It was unable to warm the planet. By the end of the Carboniferous, there is abundant evidence from South Africa, Antarctica, and Australia, which lay close to the South Pole at that time, for a widespread glaciation that lasted into early Permian times. Similar, when the breakdown of Rodinia started after we have the snowball Earth existence, the cooling event of whole our planet. This is still theory and yet still speculated, however we have more evidence that it did happen. By the late Permian times, around 260 million years ago, most of the continents has come together into or even larger supercontinent we call Pangea, and stretched from the pole to pole and was surrounded by a global ocean called Pantalassa. In the isolated heart of this immense landmass, warming climates produced extensive arid regions and deserts. And in places where there used to be tropical regions, such as northern Canada, Greenland, Scandinavia, northern hemisphere, and north central Africa, Arabia, and northern Australia, in the southern hemisphere, become very dry land. You can imagine, because the moisture will not reach in those areas. The coming together of these all continents led to a great reduction in the area of continental shelves and shallow seas. And it might be one of the reasons why we have this major mass extinction at the end of the Permian. So Pangea survived intact until late Triassic times, around 210 million years ago, when a fissure opened in its eastern side, widening into a new ocean known as Tethys. We all know this ocean as the remnants of it are in the heart of Mediterranean Sea. And that's the place where we find the oldest sedimentary rock of oceanic crust. Nevertheless, the evolving land reptiles, especially the Archosaurus and the Dinosaurus descendants, still had common representative across Africa, Laurentia, and Asia. The deserts persisted in tropical regions, but the breakup of the supercontinent was now well underway. The rift formed between Laurentia, New Jersey, and northern Africa, Morocco now. The Central Atlantic Ocean began to open up, and that's the birth of our Atlantic. During subsequent Jurassic times, 199, 145 million years ago, further rifting between Laurentia, Eurasia, and Africa allowed the Tethys Ocean to extend westward, eventually linking up with the newly opened Central Atlantic and across to what we now call Pacific. And that's the time when the world became dominated by two known supercontinents, Gondwana in the south and Laurasia, Laurentia, Baltic, and Eurasia in the north. What was the effect it had on the life? From that time, the evolutionary started changing. The Mesozoic separation of Gondwana was enormously important, and now northern and southern fauna were free to evolve along separate evolutionary tracks. Further disintegration saw eastern Gondwana begin to split from Africa with the opening of the South Atlantic from mid-Jurassic times, 175 million years ago. The two finally separated in Cretaceous times, about 145-65 million years ago, and this jigsaw match between Western Africa and Eastern South America, the classical example that proving the continental drift, can still be traced today. And around the same time, India began to break away from Africa, and the Indian Ocean started opening up. Australia and Antarctica broke away with the formation of the Southern Ocean we call now, or the southern parts of the main oceans. Finally, in Paleogene times, 65-23 million years ago, Australia and Antarctica separated as the Southern Ocean widened. And 23 million years ago, the opening of the Drake Passage isolated Antarctica from South America. And you can see that we can trace this through the geology, sediments, and also the evolution of life on our planet. We call it biogeography. If you ever study that, that's specific places where specific type of animals could be found, and then you can trace back how they branch with other type of animals, how they evolved through the pre-ancestors, and by doing this you can actually see when the land started being broken off and the evolution changed its course. It's a very fascinating and interesting part of the geology science. If you're interested in that, you can explore more and study towards that. And you can see that the constant float of the continents, when they're brought together and separated again, have an effect not just only on our life, but also on the climate of the planet, which all interlinked with the life here. If you like this type of video, and I see it by the number of views, I will make more videos about supercontinents, which one exists in the past, what was happening with them, and we can explore more into the past history of our planet. Meanwhile, like this video, share it with everyone, and I will see you in my next video.